Assalamu alaikum. It's presentation of organic chemistry course instructor Dr. Atif Ali Altaf. My presentation topic is resonance and its rules. My name is Ali Hassan, roll number 5044. Resonance and its rules. First of all, we talk about the resonance background. Many times more than one equivalent Lewis structure can be written for a molecule or ion. Most of the time हम लीव किसी एक मालिक्यूल के लिए एक से ज़्यादा लिविक स्ट्रक्चर लिखते हैं. फॉर एग्जांपल कार्बोनेट आइन 3 equivalent Lewis structure could be written for the carbonate ion, and these are the 3 Lewis structure of carbonate ion, in which there is the delocalization of electron, means the shifting of electrons are occurring. Then one structure could be changed into other by changing the position of electrons, as we can see that there is the position of atom is same in all the resonance contributing structure, but there is the moving of electron from one atom to another atom, and there is the delocalization of electrons, pi electrons. Each atom in structure has noble gas configuration. As we see in the structure, the valence shell of each atom is full, and it has the noble gas configuration. As we see, if we see the oxygen atom, there is the 6 electrons, 3 lone pairs and 1 bond pair, means total 8 electrons are present in the valence shell of oxygen, and all the atoms in the 3 resonance contributing structures, all the atoms have complete valence shell and noble gas configuration. Carbon oxygen double bond is shorter than the single bond. If we see from the structure, the carbon oxygen double bond is stronger than it has shorter bond length, and the carbon oxygen single bond or sigma bond will have the, due to weakness, will have the long bond length. But the structure does not agree with the evidence of all the bonds have equal length. But when we experimentally, जब हम चेक करते हैं the bond length of the carbon oxygen atoms, then all the carbon oxygen atoms have a same bond length. Then there is no difference through any spectroscopy type like X or D. There is no difference, means the resonance structure which we are, or Lewis structure which we are written, are only theoretical. Resonance introduction. Theory of resonance. According to this theory, many molecules and ions are best described by writing 2 or more resonating structures, and the real structure is waved average of all the contributing structures. Means the resonance explain the molecules which are difficult to explain, and they have the complexity in their structure. The resonance contributing structure help us to understand them easily, and the real structure is the waved average of all the structure, means the real structure have the properties or the features or the composite of all the resonating contributing structure, and the single resonating contributing structure is not able to explain the original molecule. It was given by Linus Pauling in 1930. Then contributing structure. Individual living structures are called contributing structures, means the structures which we are written for the understanding of the molecule are called Lewis structures, are called contributing structure. We also call them resonance contributors or conical forms. Then the second one is resonance hybrid. The real structure of molecule is called resonance hybrid because it has the features of all the resonant structures, as we discussed before. The the resonance hybrid is the composite of all the resonance contributing structures, and it has the features of all the resonance contributing structures. Resonance, the phenomena in which a species through two is described through two or more contributing structure, but the position of the atoms remain same, is called resonance. Resonance is the phenomena in which the species is a molecule or ion which is described through different contributing structure, but the position of atom is remaining same and there is the movement of electron. Then this is called resonance, and it is the delocalization of pi electron, means there is the delocalization of electrons from one atom to another atom, and the position of the nuclei remain same. Then the resonance features. None of the resonance structure is the realistic for the representation of molecule or ion. It's only for the understanding the complexity of resonance hybrid. As we see from the structure, the bond length seen different, but the originally from the XRD experiment, the bond length of the oxygen carbon bond are same. Then it seems that these are the theoretical, the resonant structures are only the theoretical and can and they are and the original structure is different. But to explain, to understand the original structure, we write the resonating contributing structures. The actual molecule is better represented by the resonance hybrid of these resonating structure, and the original structure of molecule we can't written on the paper, and we write the resonance hybrid, means the composite of all the contributing structure through which we can get better understanding. And the resonance structure exists only on paper, means this is the theoretical and we can only written on it on paper. Resonance rules. First, resonance rule structure exists only on paper, means the resonance structures are theoretical and we only written on them on a paper, and these are connected by a double bond or double headed arrows. As we seen in these structure, there is the double headed arrows between these resonance contributing structure. The second rule is only electrons are allowed to move in writing resonating structures. The position of the nuclei atom must remain same in all the structure. As if we see in this structure of carbonate ion, there is the as denoted through the arrows, the there is the movement or of electrons. There is the no movement or change in position of atoms. There is the change in position of electron or delocalization of electrons, and change in position of double bond, and there is change in a negative charge on all the oxygen and on the atoms of this carbonate ion. Then the third rule is all the structure must be proper Lewis structure, means the resonating structure which we are writing must be the proper Lewis structure, as as not more than two electrons in hydrogen, as hydrogen has only one subshell s and there is only capacity of two electrons. Therefore the hydrogen had only should make one bond. If hydrogen make more than one bond and containing more than two electrons, then the structure will be not a proper Lewis structure. The second one is that not more than 8 electrons in outermost shell for the third. For the second row, second period, like carbon and nitrogen, means the second period at elements has two subshells S and P, and there is the capacity of containing 8 electrons. Containing 8 electrons means they can form 4 bonds. So there is the capacity of 8 electrons. But if any atom if any element contain more than 8 electrons and forming more than 4 bonds, then there will be not a proper level structure. There is no resonance contributing structure. Not more than 12 electron in outermost shell of third row, like phosphorus and sulfur. As we discussed, the third period elements have the capacity of to has the capacity to contain 8 electrons, as we have formula 2ns square, and but they only reach the 12 electrons due to the size and other reasons. So the if any element exceed the 12 electrons, the number of electrons, then there will be a not proper Lewis structure. And the other fourth one is all the atoms involved in resonance must lie in same plane. As we seen as we seen through this example of cyclohexachlorooctane. So there is the plane of this is a change. The it has a tub shaped like structure, and there is the plane is changing. So there is no resonance contributing structure, or there is no resonance, because the resonance must lie in a same plane. The fifth rule is the number of unpaired electron must be the same in all the conical forms. Means the all the contributing structures, all the resonance contributing structures which are theoretical and we are writing for the understanding, must have the same number of unpaired electrons. And if we see in this example of oxygen O2 molecule, and there is in first one there is both oxygens have two unpaired electrons, and there is only two lone pairs and two lone pairs, but the fourth one there is the unpaired electrons are different from the others ones. So there is this is different from the other, and no have no same number of unpaired electrons. There will be, this will be not the resonance contributing structure of a O2 molecule, because it has the different number of unpaired electrons from the other ones. That's it. Next one is the structure of with distorted bond angles or bond lengths will not contribute or will make the little contribution. इसका मतलब ये है कि दो वो मॉलिक्यूल्स जिनकी जिनकी बॉन्ड लेंथ डिस्टॉर्ट होगी या बॉन्ड एंगल्स डिस्टॉर्ट होंगे, वो उनकी कंट्रीब्यूशन कम होगी, मीन्स वो लेस स्टेबल होंगे. As we seen through the example, the first two benzene structures are the more stable and the other three ones are the less stable, because these have first two have the 39, each have 39% contribution, and the next three ones each have the only 7% contribution, because in this we can see the bond length of is greater than the others. So there will be the bond length is greater and the bond length will be distorted. So there is a will have little contribution, or this will be less stability. The next one is the resonance hybrid is lower than the any contributing structure. Means the energy of the resonance hybrid will be less than the any रेजोनेंस कंट्रीब्यूटिंग स्ट्रक्चर, इसकी एनर्जी रेजोनेंस कंट्रीब्यूटिंग स्ट्रक्चर से कम होगी रेजोनेंस हाइब्रिड की. द रेजोनेंस स्टेबलाइज अ मॉलिक्यूल और आइन. इफ रेजोनेंस structure and equivalent, then the stabilization is large. If the all the resonance contributing structures are equivalent, mean have same bond length, then there will be large stability, there will be more stable the molecule. Contributions of resonance, stability of resonance structure. The more covalent bond a structure has, the more the stable it is. Structure without a change are more stable. Structure जिसमें बहुत कम changes हों, this will be more stable. The third one is charge suppression decreases stability. Structure with more negative charge on a more electronegative atom are comparatively more stable. Means if we have a molecule and there is the difference of electronegativity, and the atom with which is the more electronegativity, and it is containing the negative charge, then the bond will be, then there will be, the structure will be more stable. And the fifth one, the structures in which all atoms have complete valence shell of electron, they are more stable. if अगर हम स्ट्रक्चर ऐसे मालिक्यूल का पढ़ रहे हैं जिसमें के एटम्स का वैलेंस शेल कंप्लीट है, देन देयर विल बी मोर स्टेबिलिटी देन द अदर ones. So this is the presentation of organic chemistry. Thank you.